In this lecture, we will continue our discussion on theorems on open sphere and open set. In a metric space, a set is open. If and only if it is the union of some open sphere proof. In the statement of the theorem, it is asked to show that a set in a metric space is open if and only if it is union of some open sphere. So, right, let X be a metric space and G be a subset, of X. First, we assume G is open. To show G is union of some open sphere. As G is open, there arises two cases, either G is empty or G is non-empty. If G is empty, then we have nothing to prove. G is a union of class of empty class of open sphere. So, alright. If G is empty, then G is union of open sphere and if G is not empty, then we will proceed with the proof. That is, then for all X in G, as G is open set, there exists some real number R. Greater than 0. There exists some real number R greater than 0, such that SRX subset of G, as X is an arbitrary element of G, then G is my union of all such open spheres. Therefore, G is union of all the open sphere SRX for X belongs to G. Okay? So, for all X belongs to G, there exists some real number R greater than 0 such that open sphere SRX containing G. As X belongs to G is arbitrary, that means G is equal to union of all the open sphere for whose center belongs to G. Secondly, we will assume G equal to union of all open sphere. We will going to show that G is open. Secondly, let G be union of open spheres to show nothing to do, G is open as empty set is open, then G is open if G is not empty, then for all x belongs to G, x belongs to union of SRX. That means x belongs to some open sphere, x belongs to at least one open sphere of this union. If x belongs to G, G is equal to union of open spheres for whose center belongs to G. That means x belongs to this union. If x belongs to this union, that means x belongs to at least one of this open sphere. That means x belongs to SR naught, x naught for some R naught greater than 0, R naught greater than 0, and x naught belongs to G. Okay? As SR naught, x naught being open, we know open sphere or open set. So this open sphere is an open set. There exists some real number R1, real R1 greater than 0, such that SR1X is a subset of SR naught, X naught. X belongs to this open sphere, and open sphere is open set center at this point for some real number R naught. For some real number R1, we will get an open sphere SR1X that is contained in SR naught, X naught. That means this SR naught, X naught being subset of G, therefore SR1X is a subset of G. This implies G is open. Hence the theorem. With that, I would like to conclude. Remaining will be in the next lecture. Thank you.